Here's pre-calc, it's problem 3-77, and it says, given f of x and g of x, sketch the graphs of the two functions. So we kind of spent the first part of the school year learning about the cubics and the parabolas, and we know the parameters a, h, and k. So this one we're supposed to kind of just know that this is a cubic that is shifted up by 1. So it should have a shape like this, and it'll be shifted up by 1. This one is a parabola. It's going to be shifted left by 1. So it'll have a shape like this. So I'm going to actually graph them, and I don't want the video to be too long, so I already graphed them. So the cubic, it's hard to tell. I did the best I could. Here's the cubic. So I knew that it was a cubic shifted up by 1. So right here is my locator point. Instead of at the origin, it's right here. And then I did have to use a few points just to get my graph a little closer to being accurate. So I just plugged in 1. 1 cubed plus 1 gave me 2. So I know 1 comma 2 is a point on the graph, and then I know that this graph has a kind of a symmetry, so that gave me this other point down here too. And then I plugged in 2. 2 cubed is 8 plus 1 is 9, so I knew that it had a point at 2 comma 9. So that's this one way up here, I believe. This is 9. It's right here. Okay. So that's how I graphed it, and then I went ahead and graphed my parabola. I know that parabolas normally go through the origin if it's just y equals x squared, but this one was shifted left by 1. So I got my vertex right here, and then I just made a little teeny table, and I plugged in 0, and I got 0 plus 1 is 1, and 1 squared is 1. So I got 0 comma 1. So that gave me this point. I know that parabolas have a symmetry. This is the vertex, so I know there's another point right here. I used 1. I got 1 plus 1 is 2, and 2 squared is 4. So I had 1 and 1, 2, 3, 4. So that's this one right here. I knew there was another one on the other side, so I put 1 there. And I plugged in 2, and I got 2 plus 1 is 3. 3 squared is 9, so I got 2 comma 9, and that ended up being right here. Actually, I think both graphs share this point right here. I don't know if that's going to come into play later, but so there's my two graphs. So that's letter A. It's kind of hard to tell, but the parabola is like in the blue, and the other one, the cubic, is black. Okay, so what's f of 9? So f is a cubic, so I want to know where the cubic is equal to 9. So I can actually just look at my graph, because the cubic actually hits 9. What's f of 9? Oh no, what's f of 9? f of x equals 9. Let's go ahead and solve that. So f of x equals 9. So I'm going to put 9 in for f of x. So I'm going to say, where should I do it? Right here. 9 equals x cubed plus 1. So let's see what we get. Eight equals x cubed. 8 equals x cubed. So if I cube root both sides, the cube root of 8 is actually 2. So x equals 2. And then, is that really true though? Like when I look at my graph, isn't x 2 where this cube root graph is 9? So that's cool. Okay, g of x is 0. So g of x, where's g of x 0? Let's go ahead and do it algebraically. I'm going to say 0 equals, remember g of x was x plus 1 squared. I'm going to square root both sides. The square root of 0 is 0. And the square root of x plus 1 squared is x plus 1. Minus 1 from both sides. I think x equals negative 1. So that's the answer for letter C. And I'm going to check that because, let's see, g of x is the parabola. And is g of x actually 0? Is x 0 when y is 1? Yes. So that's true. F of negative 7. So I'm going to go negative 7 is equal to the f function, which is x cubed plus 1. So I'm going to minus 1 on both sides, and that gives me negative 8 equals x cubed. Cube root both sides, and the cube root of x cubed is x, but the cubed root of negative 8 is negative 2. And is that, so that's what I get from my answer, and is it really true? Probably. My graph isn't very perfect. So I can check the answer key though and make sure. Yeah, it is. So sometimes the graph, it's just a little hard because see how my graph is pretty imperfect down here? So you can always use your algebra. G of x equal to 12. So if g of x is equal to 12, I could just look up at 12 and see what I think it is, but since my graph is kind of imperfect, I'm going to go ahead and solve it algebraically. So I'm going to say 12 is equal to, g of x is x plus 1 all squared. So square root both sides. So I get the square root of 12 is x plus 1. So, and then I'm going to subtract 1 on both sides. So I have that x is equal to negative 1. The square root of 12, let's do that over here. That's like 4 times 3, so that's 2 root 3. So I think I'm going to get negative 1, I kind of ran out of room right here. I'm going to get negative 1 plus or minus 2 root 3. And I did my scratch work over here. Okay. So then f of x, when does f of x equal g of x? Well, it just says for how many values of x does f of x equal g of x? Kind of hard to tell on my graph. I think they cross at 9. And then I think they cross here and here. So you could, honestly, you could just get out Desmos and make it, and find out for sure how many times they cross. But I think they cross 3 times. And now I'm very sorry that my graph is not very precise. But so just put it in Desmos so that you can be positive that they graph, or that they cross 3 times. So 3, because the graphs intersect 3 times. So you can just, like I said, put those in Desmos. And then is each graph, are each of the graph functions even, odd, or neither? So let's look at f of x. F of x is a cubic. Is it even, odd, or neither? Well, it's not even because it doesn't reflect across the y-axis. It could be odd if it had rotational symmetry about the origin, but it does not, unfortunately, have rotational symmetry about the origin because it got moved up by 1. So it does have rotational symmetry about this point right here, but that's not the origin. So we're going to say that's neither. And g of x, normally a parabola, if its vertex is on the y-axis, then you could say that it's even. But this one's vertex is off to the left by 1. So this does not have symmetry about the y-axis. So this is also neither even nor odd. And that is all.